75 milligrams per. Okay, so we're not giving grains, we're giving caplets, right, or tablets. So the thing is, what we need to do is get this into milligrams first before we can convert the amount, the dose, into how many caps we're taking, right? So actually, let me move this part over here. So this will kind of be like next to our last step where we actually convert the amount of stuff into what you're actually having the patient take. So now this one is just downright annoying. What in the world is that?
Yeah, that's what I did. Okay, yeah. There was like some really weird ones on there. I don't know what that is.
Yeah, so in Roman numerals, SS is half. I think we talked about that one, but it's not, briefly, it's not intuitive, but that's what it is. And of course, now you are familiar with that one and that one, that one, but then as it went down, then it starts to become fuzzier again, right? Anybody remember what the next one was? L, C, D, yep. There you go. Yeah. So, but actually, one thing that helps a little bit, at least these are in alphabetical order. Right? Because you already kind of know those. There's the odd duck, and then these are in alphabetical order. It helps a little bit. And actually, this is another word for century. So that helps you, right? I don't even think of what those would stand for. Okay, so now coming back to this, so another way to write this, and what I'll do is I'll take out, instead of, so again, we know that that's 1.5, but let's do it this way. Let's do it as 3 over 2. Okay with that? We could do it as 1.5, but we're going to make this into a fraction anyways. So let's go that way. Decimals in fractions are just kind of bad taste, I guess. I don't know. So we want to get rid of grains, so what do we do next? So grains to drams, yep. And then we want to get rid of drams to, good. Ounces, how can we get rid of ounces? Okay, pounds. And now I'm going to run out of room, so now I have pounds to kilograms, then to grams, grams to milligrams. And once you can do that, you almost have this stuff licked. Okay? This is just downright annoying. But the easy part's really kind of thrown in the numbers now, right? Once you see your path, so we've got 60 to 1, we have 8 to 1, we have 16 to 1, we have 2.2 to 1, we have 1 to 1,000, we have 1 to 1,000. Okay, and when we're all done with this, we're going to be left with milligrams, right? But we don't even want those. We want this, and what are we going to do with that? Flip it so the milligrams are in the denominator. So we have 75 milligrams, 1 of those. Okay. So what's it come up to be? It is something, yes. I'm hoping 3 would be a nice answer. 13 just really doesn't seem right.
This is when you heal the patient.
Yeah. It's like, oops. You just got 1,000 times. Yes.
When I did this one in homework, I couldn't figure out what the FS stood for. So I just picked a random number and guessed, and I was right. I was like,
nice job.
I did that on, but I was very excited.
Is that where you wanted to really, if you're going to be so lucky, wouldn't you want to pick the lottery number instead or something?
I know. I was
right?
like, I should go buy a lottery ticket.
Man, you just used up your luck right there. 1. Okay, what'd you get?
0.118.
Oh, that's not very nice. 118. Somebody else do that? Get the same number? No calculator today? Get your phone.
I did 1 grain is 60 milligrams, so I just converted that.
Well, now where'd you get that from? Yes. So,
I got my answers on Pearson.
right, you did. You did. Yeah, and so yes, you can get through Pearson, just Google straight through it. The catch is when it comes to the test next week, and it's only next week, you're going to have that table, less the ones that were highlighted, right? Those are the conversions you need. And the reason I chose that is because this is what we're trying to learn. You're right, you can Google any of the answers. What we're really trying to learn is not medical doses, we're trying to learn dimensional analysis. Okay? 1.18. Okay, like that? Okay, so how much are you going to give them?
1.
Just give them 2 for a good measure? No? Yeah, give them 1. It's probably a good thing.
Yeah, you can do the 90 divided by 75, you get 1.2.
Yes. But again, I preface it, again, I'm tempted to take out this whole Pearson textbook next time because it,
I think you should. I've
Well-
never used it.
well, when we get to next week, especially these chapters, I want to ask you that question again, okay? I'll let you just keep doing it and see if it's useful. But we couldn't find a book that really asked the level of question we're after, which is, of course, then why I tried to give you those extra questions as well. So again, I mean, that's pretty obnoxious, but going through the process, that's what I want you to learn, okay? I'm not thinking you're going to have to convert grains into a caplet like that, but I think if you can do that, you've learned what I want you to learn, okay? Any more of those you want to talk about?
I have a question about rounding. If
Yes.
you got 3.5 for an answer and Pearson says it's 4, if it's a tablet, you just round up to the next whole tablet?
So as far as trying to make Pearson happy, they mess up on the rounding rules all the time anyways. So from that standpoint, don't lose any sleep over it. 3.5 would round up to 4. You know, I was actually asking
They ask for a fraction.
and sometimes they'll tell you decimals or fractions, or so sometimes you just have to hop through their hoop. And if I could change that, I would. And if I could run the course without Pearson, I will do that too. We'll see. That's an ongoing conversation, which I would like your opinion when we get to the end of the course. Okay, I have a little survey for you to take just on that topic itself. But yes, when it gets to rounding though, like the 3.5, my understanding is if, for example, if it was for a kid, you would actually probably round it down. But if it's an adult, you tend just to use the regular rounding rules. So that's the latest on that. But please don't quote me on that. When you get to your other courses and they actually teach you med stuff, then do what they tell you there, okay?
There's one too that I got 3.2 on, but it still would only take 4. Would you let me go down or use 3.2?
So now that one should have, according to regular rounding rules. Now, it could be we were running into a situation, I'm not sure which problem you're looking at, but especially with a lot of the apothecary stuff, it depends on how many digits you use in your answer here. Because one of the textbooks I have, it will say, what's the one? Oh wait, they'll say it's either 4 or 5 milliliters. I can't remember what you start with. It's equal to either 4 or 5 milliliters, which means right away you're 20% off, depending on which one you choose. Okay, so that with the apothecary stuff, there's a lot of rounding error that goes on, and maybe that's what was happening there. Any more questions? Mariah, did that help at all?
Yeah.
Okay. You just had no idea it'd be that
No, I
ugly.
missed Friday, so I think that.
Oh, could be. I figured you were saying no, it couldn't be that bad.
Ridiculous. Got a few other steps, but I understand.
Mhm.
That's what you're supposed
Okay. So ready to continue on? Anna, what are you thinking?
Well, I can ask for this afterwards, I'm thinking, so we can work on this.
It might help everybody though. So
I'm just wondering, when you have like grains, it says, so sertraline, HCl grains, 5/12 orally, how would I put that into equations that makes no sense? Because I was doing it and I can't remember how I was doing it.
So you're saying 5/12 of a grain?
Yeah.
Okay. And then again, is this one where it comes out in terms of the tablet or something?
Yeah, I'm trying to figure out how much in milligrams it should be.
So it's going to be that same thing that whole
And
hoopla.
just do
5/12ths, and the 12th is the top.
Yes.
Okay.
Now you could have actually gone 5 divided by 12, put in a decimal here.
Okay.
But
Okay.
with the dimensional analysis, you're going to have a whole bunch of stuff in the denominator and numerator anyways.
Yeah.
So I would recommend setting it up that way.
Alrighty.
Yeah. But then you're right, it's going to be the same crazy conversions we just went through.
Okay.
Okay. I was going to have you guys do drops, practice holding an IV bag out, see if you get the drip rate right. I'll bring it over on Friday. I thought I was doing good to go to this meeting and have all this stuff there, and then I still forgot something. So. Okay, let's see here. There we go. So I think we talked about all of that. Anytime you see the word flow, if they want, or flow rate, I had this on the board yesterday, but it's worth writing a second time. Flow rates are going to come in two ways. Either milliliters per hour, especially if you're using a pump, or they're going to come to you in drops per minute. And so, but when you see the word flow rate, well, I mean, I guess the easiest way to think about this would be, we know about speed, miles per hour, right? So this isn't really miles per hour, but it's milliliters per hour. It's stuff per time is what the rate's going to be, okay? So anytime they ask you about rate, it's going to be one of these two. They may not, or they may tell you in drops per minute, or may not. They might skip that part. Pearson will have this little equation, and it works. But again, the goal here is to use dimensional analysis, so you don't have to memorize any of the equations here, okay? So we talked about this one here.
No.
Well, let's see. So if you're going to do, if you're supposed to give 17 drops per minute, how many are you going to grab your watch out? How many are you going to count? So for 15 seconds, so how many are you going to count? You're saying 4, right? Quietly though. But yeah, right, you're going to count 4 drops, right? And you're not going to worry about counting quarter drops. Right? 17. Are you following me? Okay, couldn't tell there. All right, so the next question here. What's flow rate? So it's going to be one of those two. So we are given D5W. Do you remember what that means? It doesn't matter to the problem, but
5% of dextrose in water.
that's right, 5% dextrose in water. Yeah. So no saline there. We have 1,000 liters in 8 hours. See, and this, so the drip set, remember the little drip chamber I showed you? So it's going to give us 15 drops per 1 milliliter. And in fact, I think there were a couple problems in Pearson where they forgot to tell you the drip rate, but it works out for 15. So just to give you a little heads up on that. Just it's a mistake on Pearson's part, but it'll get you to the right answer, which is really tragic. So what do you think the flow rate should be in this case? Do you think they're asking for this one or for this one? So they'll actually be asking for drops, and the reason is they happen to give you the conversion. So it's one of these things you have to kind of guess. So, but if we started off with the first one, if we just want milliliters per hour, how would you write that? Yeah, you just do that. I mean, it's going to be that easy if it's milliliters per hour. If we think they want drops per minute, and since they've given us this conversion factor, we should assume that. So now how can I convert this into drops per minute? That's the question. So here we already do have the flow rate in milliliters per hour. You could just do the division if you wanted, but what now? So this is what we want to have for units. And we're starting out over here. How can we convert that?
Don't we have to add the 5% of the dextrose or not yet?
No, that is simply telling you what this is made up of.
Oh, okay.
So in fact, we don't need that information at all.
Okay.
Yeah. It could have been 5%. It could have been D, 5, 1/4 NS, and it wouldn't have made any difference. It would have made a difference to the patient, but to us, right now in the math world, it doesn't make any difference at all. So, I don't want hours and I don't want milliliters. How can I get rid of them?
Hours to minutes.
Okay, so let's do that. So 1 hour is 60 minutes. Okay, so good, we've got rid of that. And that is in fact what we want there. Now how can you get rid of the milliliters?
Would you go to ounces and do tablespoons and then back down?
You could, but in this case they gave us one more piece of information that makes it much easier.
It's 15 per minute.
There's 15 drops per milliliter, right? So the milliliters, I need that to go in the denominator, so I'll just put in here my 15 drops per 1 milliliter. Now you can see that the milliliters go away, and we're left with drops per minute, which we want, right? And when you do the math, what do you guys get out of that?
I got 31.
Okay, so how many drops are we going to actually count?
So 31.
31, yep. It's kind of like the problems where it's 7.8 babies, so we no, just 8 babies. 31 drops. Okay. And I'm pretty sure Pearson's not going to want a decimal in this one. I'll be really disappointed in him. Any questions on that one? Okay. Let's go try this one. 500 mils in 3 hours. What's the flow rate? Okay, so how would I start off here, Hannah? Yep, there you go. That's it. Yeah. Okay. The units are right? We get milliliters per hour. We don't have any information about the drop stuff, so it's as simple as that. Okay. That's going to be the hard part, is how do you know when it's an easy problem, when it's not? Okay. So this one gets messier, quite a bit messier. Okay. Ultimately, we want to know the flow rate, right? And since they do give us a conversion there to drops to milliliters, we can pretty much bet the final answer should come out in drops per minute. And you're already a little nervous since I had to write on the other side of the board, probably, right? Okay. So one thing that will help you in sorting all these out is if we have stuff per time, right? Obviously, we're going to get pickier as we go. But when you look at all that information up there, so there's 500 milligrams in 1,000 milliliters, right? So we should write it like this. 500 milligrams in 1,000 milliliters. Okay? So we get to chop out all those words. It's not as clean as if it said per, but it really means the same thing. Okay? And then we have the D5W, which is just a little smoke screen there, so we don't need it at all. And we have 0.02. Now notice that's milligrams per what? Actually, let me write this out for you. 0.02 milligrams per kilogram, right? Where do you put the minutes at?
You multiply by that.
You do. So that may not be intuitive to you, but so when you see a stack of divisions like that, what we're saying is the milligrams are divided by kilograms and they're divided by the time. Okay? So this is the correct way of interpreting what we have up there. Okay? And then see what's the next one we have. See, the person weighs 176 pounds. And we know we have 15 the drip set is 15 milliliters, 15 drops per 1 milliliter, okay? So that's all the information we're given. And I think it's kind of helpful to get at least down into these fractions as much as possible. In fact, I could even write it like that. So now the only gets more of a puzzle, just how do you rearrange those little fractions, okay? Again, going back though, we have stuff per time, which means we're off to a good start, okay? That's, I guess, the way you can tell that you don't do it the other way around. If I have kilograms and minutes over top the milligrams, then my units start off not even being possible, okay? Not so impressed with that, Hannah? Okay. Please ask lots of questions. I'll try to. So I'm going to start here with stuff per time. And now I need to manipulate these units until I get into my drops per minute, right? So there's several different ways you can do it that are all correct. Anyone want to suggest a starting point?
Flip the 500 milligrams over 1,000, flip it.
Flip it? Okay, because then I'll get rid of that milligrams, right? Good. So we just let the dimensions kind of show us where to go. So I'll do 1,000 milliliters over 500 milligrams. Those cancel out. Beautiful. What else can we do?
Do you have to get rid of the kilograms? Is that
We do.
okay? So do you convert that to
176 pounds to
pounds?
So, we could do it two different ways. One is we could go over here and do a side problem and do the conversion to kilograms. That would work just for fun. Or kind of take that loosely. So to get rid of kilograms, I could put kilograms here, right? Which means I would put pounds here. And what would be the relationship between those? To 2.2. And then I could grab this guy right here, and I would put it like 176 pounds, like that. So I get rid of my kilograms, and I get rid of my pounds. Because we don't want that information when we're all done.
And then
We're getting close.
yeah, we need to convert the milliliters to drops.
To drops.
So
And in this case, they told us the drip set
okay.
that we're using.
Flip it.
Yeah. Right, it's going to just go straight in, isn't it? Because our milliliters is on top, so we'll write this as 15 drops per 1 milliliter, so then I can cancel my milliliters out. Okay. And what happens when we multiply these all together?
That's 48.
For the total answer? And if somebody happens to run into the numerator here, tell me what that is. 48 drops per minute.
52,800.
800. Yep. When I'm grading your work, it's nice when I can see these interim steps. Helps me a lot to know where it was going for you. How'd that go?
Great.
Not so bad after? Or as bad as you expected? Worse than you thought?
Peterson makes it really, really easy compared to the ones that we actually do in class.
Was that?
Peterson,
Pearson?
whatever.
Well,
Starts with a P. It's
The-
really easy compared to the ones that we do in class.
yes, and that's the problem. The book is too easy.
It is.
And that's why I want to get rid of the book. But I can't find another book. There's another book that was closer, but we can't get it with the online stuff, and we couldn't merge it. So my thought is I could almost take the worksheet I gave you, make it 2.5 times bigger, and call it good. But we'll talk about it next week as you go through it, okay? Yeah, Pearson kind of dumbs it down a little bit too much for us. This is what we're shooting for here. All right, let's see. A couple more of these. Oh, we just did that one. So this is a different question. how long is it going to take? So we're going to give 100 mils. Start at 8:15 in the morning. We have a flow rate in milliliters per hour. Okay. So the question is, when will it be done? So what are the units we are shooting for out here? Our final time. Yeah. So we want time, and we could either have this come out in either hours or minutes, depending on what you might. So, any idea how we would start this?
Started off with the flow rate, right?
So let's grab the flow rate. We have 125 mils per hour, right? If I were to write it as mils per hour, notice where my time is in the denominator, right? But really, when I think about it, that's what I want to have over here. So let's flip the flow rate, okay? And again, the reason we're doing it is because we're looking over here thinking we want hours to be in the numerator, not the denominator, right? So I'm going to write that as 1 hour over 125 milliliters, like that, okay? And then, of course, but I really don't want mils in my answer, so what will I do?
The 1,000 milliliters.
That's right, so now I'll put the 1,000 milliliters right here, and I can just put that over 1. So now those cancel out, and so what does that come up to be? 8 hours? Good? Now, one more part to this is this started at 8:15 p.m. So now when I add 8 hours to that, what time is it really going to be?
4:15 a.m.
Yeah. Okay. Now, this is not the question they asked here, but let me make this slightly more complicated, okay? So, what if when you did the math here, it wasn't such a nice clean 8, but it was let's go with 4, 8.4 hours. How are we going to do that? How are we going to handle that? Now, to get to our stop time. Do you know how to do that? It might be tempting just to somehow take the 0.4 and add it to that. But that that can't be right, because this is actually like almost 30 minutes, right? It's going to be 25 minutes or something of that sort. So we actually, before we can do the addition here, since this is actually minutes and hours, it's not a decimal there, we need to take this part over here and we need to convert it to minutes. Okay? So here's how you do it. 0.4. So this is actually like saying 40% of an hour. Okay? That kind of makes sense? That means I will multiply it by, we have 60 minutes an hour. So then I'm going to have 24 minutes. Is everyone okay with that? So now I can come over here and I'll actually do the addition as 8 and 24 minutes. So now I can get 15, 19. Come on. Did I do that right? So everyone okay with that one little step there? I think if you think about it for just a minute, it kind of makes just a lot of sense, right? It shouldn't be something you have to do a lot of memorizing of. I think let's have you guys start this one. Okay. feel like you're kind of starting in the right direction, or not so much? So it's kind of like that. Now, did some of you actually, though, continue to make this minutes into hours instead? You did that next? Yeah. So we could do that. You can kind of work the problem either way, but if most of you are going that way, then let's go with 60 minutes, 1 hour. Come on, I can do this. There we go. How many hours you come up with? Okay, so then just like before, we're going to grab this, bring this over here, 0.63. I'm going to multiply that by 60 minutes. Was it like 37? Oh, 38 minutes. Okay, we'll go with that. And see, we are at 3:30 p.m. and we're going to add to that 4 hours and 38 minutes. And actually, what happens in this case when you add the minutes? More than the next hour, right? So we're not 7, we're actually at 8:08 p.m. Okay. Was everyone pretty close? Yeah. And so there's nothing wrong with that. The only reason I picked this is this way I was positive my time was going to be the numerator. And so in this case it worked just fine the way you did it.
I just flipped the
Yeah, you flipped the order a bit. Yeah, and that's fine. So my only point would be is if you had picked, let's say you chose to start with this one and you had it in the wrong direction, what's going to happen is you'll come out over here and it might be 0.12 per hour. Okay? And so at that point you'd have to flip this upside down or redo it, whichever you want to do. Does that kind of make sense though? So if you land down here and your unit is in the denominator when you want the numerator, you actually have to flip that. So in fact, then you could also go 1 divided by the number should give you the right results too. Okay. Which is better than maybe redoing the whole problem. Okay. Enough of those guys?